Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 8 of lesson number 8, motion. So now as you all remember, like here in this lesson we have so many things to discuss with respect to velocity, acceleration, comparing the speed, uniform and non-uniform motion. And if you remember, yesterday like we saw the graphical representation between velocity and speed, and we saw like if they are in uniform motion, what kind of graph can be obtained, and if they are in non-uniform motion, in that case what kind of graph can be obtained, right? So we have studied all that till the last part. Now we are just left with few more parts, like there are equations on all, there are certain graphs and activities. So I'll try to complete the lesson as soon as possible, but before I start with it, I don't want to rush as well, I don't want to make it slow as well. Okay, so before I start with this, I'm going to show you all the slides for few seconds. I want each one of you to quickly have a glance of whatever we have studied so far in the lesson, because we have come a long way. It's part 8, right? Until now, you might be knowing all the subtopics. You might have understood, like if I give you a question to write on, you should be able to answer it as well. And why I'm telling you that you should be able to answer it, because we are revising it as well, right? So I'm going to start show you the slide. So we have started the lesson motion by discussing on like motion itself, right? We have described motion in brief along with different examples. So I want each one of you to please go through the slide once. I hope every one of you are revising it. After describing motion in detail, we discussed on motion along a straight line, right? So I want you all to please go through it quickly, everyone. After this, after discussing about motion along a straight line, we discussed on activity 8.1. So I want each one of you to please go through this as well. And you have to revise this activity by letting yourself know the observation, conclusion, and explanation to whatever you are stating. Okay? I had one of my student. She asked me like, can't we skip activities because there are so many activities in the lesson. So she was like, can we just skip this activities so that we can complete the lesson quickly? See, the reason of incorporating activities in your book is to relate the concepts to the real life example, right? Because if you can see whatever protocol that they have stated, you can easily do that. Calculating the magnitude and like the distance is not that difficult, right? Now there are many activities where you need the science lab, but the textbook is made so that you all are studying that in school as well, right? So in school there are science lab where the teachers are going to provide you with all the, you can say, materials which have been required, and she is even going to help you to perform that activity, right? So whenever you come across activity, be happy for that, because whatever concept that you are studying, you are correlating it to the, you can say, you are correlating it to the real life, right? And that is what you want now. That should be your need. Whatever you're learning, you have to think of that you should get in real life example based on it, so that you understand it properly and you don't have to rectify it again. Okay, so be happy for the activities that you have in the lesson. And as I tell you every time, whenever you feel like that you can perform the activity, don't hesitate, just perform it and see the conclusion. It's okay if you're getting wrong results. Okay, all the scientists, whatever they have come up with, that was like after the 100 200 times when they have performed the activity, then only they have came up with that conclusion. So nobody gets the result in the first try. You have to keep on trying it unless and until you're not getting the perfect result. Okay? After this activity 8.1, we discussed on activity 8.2 as well, right? So here you need to find out the distance between Bhubaneswar and New Delhi using the road map of India. So I just want each one of you to please go through it quickly. So I hope everyone is revising it along with the observation, conclusion and all. After this activity, we discussed on uniform motion in detail, so I want each one of you to please go through it quickly. After this, we discussed on non-uniform motion. So I just want you all to please go through it as well. After this non-uniform motion, we discussed on this activity 8.3. So I want you all to like revise this activity by letting yourself know the observation, explanation and conclusion to it. After this activity 8.3, we discussed on measuring the rate of motion. So I just want you all to please go through it, and as I have already said in so many parts that this part is important because here we have the SI units and everything with respect to speed which has been given, right? So please go through it, everyone. I hope every one of you are going through this slide. After this, we discussed on how to calculate the average speed. So here we have the formula to calculate the average speed, and I want each one of you to please go through it. After this, we discussed on this example 8.1 for calculating distance. So I hope every one of you are even going through it. After this activity 8.1, we discussed on speed with direction. So I just want you all to please go through it as well once. I hope everyone is going through this properly. After this speed with direction, we discussed on this activity 8.4. So I just want you all to please go through this activity. After this activity 8.4, we discussed on lightning and thunder as well. That is with respect to 8.5. So I want you all to please revise it as well, everyone. After this, we discussed on this example 8.2. So I just want you all to please go through it, everyone. I hope you all are going through it because this is going to help you a lot. This is a solved example for you. Okay. After this activity 8.2, we again have an example, you can say. Okay. So just go through it. Here we have like how to calculate the average speed and the average velocity. After this example, we discussed on rate of change of velocity. So I just want each one of you to please go through it quickly. After this discussing on rate of change of velocity, we discussed on acceleration, right? So I just want each one of you to please go through the definition of acceleration. After this, we discussed on activity 8.6. So I just want each one of you to please go through it quickly. After this, we had this example 8.4. So I just want you all to please go through it, everyone. I hope every one of you are going through it. After this example, we discussed on like graphical representation of motion. How will be the line like graph when once you draw it, comparing the motion and the speed, right? So I just want you all to please go through it quickly. After this graphical representation of motion, we discussed on distance time graph. So I just want each one of you to please go through it. After this distance time graph, here we have the table where we have the sorry, time in seconds and distance in meter is given, right? So based on this information given, we have plotted a graph over here, and we know that based on the information that we have provided, once we go through it, we are going to obtain a different graph, right? There will be variation, and it is called as non-linear variation. Okay, so I just want you all to revise it, because after this we are going to start today's part. After this, we even discussed on velocity time graph in the last class if you remember. And this velocity time graph had will be of two types again. One will be one will be in uniform motion and the other will be in non-uniform motion, right? I hope every one of you are going through this slide. After this velocity time graph, here we have more information on it, and we have even seen how exactly that graph will look like, right? So I just want you all to please go through it quickly. I hope every one of you are going through it. After this, like here we have the information on how exactly we are going to calculate or we are going to draw the velocity time graph. So I just want you all to please go through it because this is the graph that will be drawn, that will be visible, right? So I just want you all to please go through this quickly. I hope every one of you are going through this slide. So here we have the graph, like how exactly the velocity time graph for a car moving with uniform acceleration will look like. Okay. After this, here we have the velocity time graph in non-uniform motion. So I just want you all to please go through it quickly. After this, we even discussed on this activity, I guess, the time of the arrival. No, I don't think so we did, right? So we have to just plot a graph over here. So time of arrival and departure of the train at three stations A, B and C are given. Okay, and the distance of station B and C from station A is given in the table 8.4. So plot and interpret the distance time graph for the train, assuming that its motion between any two stations is uniform. It means we need to assume that the motion between any two stations, it can be between A and B or B and C, is going to be uniform. So the station name is A, B and C. The distance from A in kilometer is given, time arrival and time departure is given. Okay, so you have to just calculate it, and you have to you can say interpret a graph over here, which I want you all to do it on your own. Okay, then in activity 8.8, here we have Firoz and his sister Sania go to school on their bicycle, and both of them start at the same time from their home but take different times to reach the school, although they follow the same route. So table 8.4 shows the distance traveled by them in different times. Plot the distance time graph for the motion on the same scale and interpret. So they are like it took 25 minutes, like distance traveled by Firoz. Like Firoz took 20 minutes, but Sania took 25 minutes, right? So whatever they have given over here, you just have to plot a graph for the same. Okay. You all can just plot and try it if you're able to do it. After this activity, we have the equation of motion by graphical method to represent. So over here we will be discussing the equation for velocity time relation. Then we have equation for position time relation, equation from position velocity relation, then example. Okay, so let's see how much we can cover today. So equation of motion by graphical method. So see, whenever an object moves along a straight line with uniform acceleration means it's moving at the same speed, you can say, okay, same speed and velocity as well, you can say, okay. So when an object is moving along a straight line with uniform acceleration, it is possible to relate its velocity, acceleration during the motion, as well as the distance covered by it in certain time interval by a set of equation. And that equation that we are like the one that we are coming up with, we know it as equation of motion, because over here the velocity, acceleration, the motion and the time all is going to be the same. So the equation that we can come up with through this is known as equation of the motion. And for convenience, a set of three such equations have been given over here, where we have like velocity v is equal to u plus at, distance s is equal to ut plus half at square, and the third equation that we have is 2as is equal to v square minus u square. So depending upon different conditions, like we have the three different equations which we can use to represent this. Okay, so now know this, that u means the initial velocity, and the initial velocity like moves with uniform acceleration a. So a is uniform acceleration time t, v is the final velocity. So u is the initial velocity, v is the final velocity, t is the time, and a is acceleration, and s is the distance. So now you know all the letters that we are using over here to represent different terms, right? So now let's talk about equation 8.5. So equation 8.5, we know v is equal to final velocity. So final velocity is equal to u initial velocity plus acceleration into time t, right? So this equation v is equal to u plus at, it describes the velocity time relation, and equation 8.6 represents the position time relation. Okay, and 8.7 represents the relation between the position and the velocity, and it can be obtained from equation 8.5 and 8.6 by eliminating by eliminating the time. So these three equations can be derived by graphical method as well. Now we are going to study the relation between time, velocity and position. Like the next three things that we have to discuss, like we can represent them graphically as well, and we are going to study that itself further. So all the three equations given on screen is very important, because like further three parts will be discussed for the same thing, right? So I just want each one of you to write the equation and write whatever you find important on screen. I hope every one of you are writing it. After this, now we have like equations to discuss, but for now I want you all to like draw the graph, plot the graph on both the activities and know the equations, because we will be discussing all the three in the next part, and then there will be one more part on uniform circular motion and like two more parts for the lesson to go, and then we will be ending up with the whole lesson. Okay, so now I'm going to show you what are we going to study. Like in the next class I'm going to start with equation for velocity time relation. After that we will be discussing on equation for position time relation. Okay, after position time relation we will be discussing on the equation for position velocity relation as well. Okay, and after this, like, we have the last topic for the whole lesson, that is like, before that we have this example 8.5, where we will be calculating the acceleration and the distance traveled by the train for attaining this velocity. We'll be discussing that, and after that we have one more example where we will be discussing on the acceleration and the distance covered by the car in that time. Okay, and after that we will be discussing on example 8.7 in detail, and then we have uniform circular motion to discuss in detail, so we'll be doing that as well. And then after discussing in detail about uniform circular motion, we have the activity 8.9 to discuss, and after this we have the summary discussion for the whole lesson. We will be doing that as well. Okay, so now make sure that you are revising it so that we are not spending much time on just revising the concepts one by one. Okay, so like after this summary, we have few exercise questions to discuss, which we will be doing. But before that, I'm going to show you all the question and then I'll end the session. And make sure that every one of you are going through the questions properly. So after discussing this 10 question, we will be ending up with the whole lesson motion, and as I told you, like most probably we'll need two more parts and then we will be able to complete this. Okay, so make sure like you revise it so that we don't spend much time revising it during the part. Okay, so I'll end up this part now, and make sure you know the concepts well and you know to explain the activities as well. Okay, so I'll end up the session over here. Thank you everyone.